Now a small numerical on projectile motion 2. Two projectiles are projected horizontally, one from A and the other from B. One is projected from here with a velocity say 20 meters per second. Another is projected from here with a velocity u 15 meters per second. They can be different. Would be with velocity 20 meters per second and 15 meters per second respectively. Find the ratio of time to reach the ground. This one will follow a path like this and will reach the ground. This one also follow a path like this and will reach the ground. Now it is given AB is equal to OB is equal to OB equal to H. From here to here is H. From here to here is H. Means the one that is projected from here is at a height 2H. The one that is projected from here is at a height H. Now the time. In last lesson we learned the time to reach the ground. In last lesson we learned the time to reach the ground for horizontal projection. T was equal to 2H over G square root of that. 2 is a constant, G is a constant. So you can say T is equal to 2 over G square root. So constant, square root of that is constant. So T is equal to some constant into square root of H. Therefore T is proportional to square root of H. That is what I have written here. Let T1, small t1 is the time to reach the ground for the one projected from A. The one that is projected from here, let it reaches the ground in time t1. T2 is equal to time to reach the ground for the one projected from B. The one that is projected from here, when it reaches at this point, let the time is t2. So let us apply this. So T1 is proportional to, so for the one projected from A, the height is H plus H2H. So instead of H, I write here 2H. So T1 is proportional to square root of 2H. And the one that is projected from B horizontally, the height is H. So T2 is equal to proportional to square root of H. Since OA is 2H and OB is equal to H. Now I divide these two, T1 over T2. The proportionality constant cancels, so I am left with 2 square root H square root over H square root. This cancels, I am left with root 2. Now I cross multiply this with this, so I get T1 is equal to root 2 times T1. So it doesn't depend on these two velocities. It only depends on the height H. This distance from O to, let's say, this point is equal to A dash will be equal to this speed into the time t1, and this distance, let it be B dash, OB dash, will be this speed into the time t2. So to find this distance OA dash will be equal to t1 into the speed, and t1 is equal to 2 times, for H I write 2H divided by square root of G into 20. Similarly OB dash will be this is speed into time t2. This is given as 15 and t2 for the second one using this expression 2H over G square root of that.